Thank you. So I would like to acknowledge the traditional owners of the land, in particular the Noongar Boodja people, the lands on which we meet, and pay my respects to elders past and present. A little bit about me. I work at the Telethon Kids and the Walyan Respiratory Research Centre at the Telethon Kids. I am a basic scientist and I work across preclinical models and human cohort and clinical. My primary interest is the immune system, and I have a fascination for understanding respiratory homeostatic processes, disease pathogenesis, particularly in regards to asthma and respiratory viral infections, and early life disease risks and prevention strategies. Thank you for the invitation to come and talk. I thought I'd like to take an opportunity to explore an overview of some more emerging strategies for prevention of infections with relevance to vaccines. First of all, a few fundamentals on the immune system, which will help give some perspective of the talk. The primary goal of the immune system is to establish and maintain a state of homeostasis, status quo. A variety of exogenous, endogenous stimuli can activate the immune system to varying degrees, including low-level inflammatories, such like a stress response, a more traditional response, which is completely required to eliminate pathogens, can also be pathological or excessive in response. And this has got to do with the uncontrolled expression of pro-inflammatory cytokines. You all would have heard the term cytokine storm in recent years. Now, this can lead to chronic inflammatory conditions and also tissue damage and organ failure. The immune system can also misbehave in other ways. It can respond to stimuli that it shouldn't and lead to diseases like asthma, autoimmunity. It can also completely under-respond. In the case of pathogens, this is really bad news because the pathogen will just continue to replicate and cause a lot of damage. So there's a fine balance, and the immune system has to really control the pro-inflammatory effector mechanisms together with immunoregulatory mechanisms. Of course, there are some contextual situations whereby regulation of the immune system is not optimal. These include during underlying chronic conditions, also include during early and later life, and during pregnancy. Now, the immune system is continually modulated during life. Gene-environment interactions modulate how our immune system works. One of the main mechanisms via which this operates is epigenetic modulation. I'm sure you've all heard of the term. Essentially, what it is modifications which are reversible of DNA or histones that impact gene transcription, including all of the things necessary for inflammatory mediation. So our immune function over life is continually changing. Post-stimulation, we do not bounce back to pre-stimulation homeostatic levels. Things continually move and change. We're continually learning. Well, let's introduce the word, our immune systems are being trained. During early life, due to plasticity, environmental gene actions have a particularly big effect, and they're very vulnerable during early life to manipulation and changes. Now, these gene-environment interactions can either be beneficial and decrease risk for disease, or can be detrimental and increase your risk for susceptibility to diseases. Traditionally, the vertebrate immune system has been divided into innate and adaptive arms. Innate immunity is mediated by a variety of cells. It's an immediate response, Pathogens are recognized via the expression of surface array molecules on the surface that recognize pattern recognition receptors. They're called PRRs. It's a rapid response and involves antimicrobial activity, including cytokines, cell mobilization, antimicrobial peptides, secretory IgA. The adaptive immune system is a slower response, principally involves T and B cells, and is instructed via specialized cells of the innate system. It's antigen specific and facilitates the process to facilitate development of long-term memory, and of course, enhanced pathogen clearance on second challenge. Now, generally it's been considered that the innate system does not have memory, the adaptive system does have memory, and this is where vaccines are principally targeted towards the adaptive arm of immunity. This has actually posed some interesting questions evolutionarily. Vertebrates are the only species that have adaptive immunity. All other species develop memory through their innate systems. It's posed a bit of a conundrum. Recent studies, however, in the vaccine world have helped us in understanding this. In fact, several vaccines, including smallpox, polio, inactivated influenza, measles-containing viruses, and in particular BCG being the most well-studied, have non-specific effects. BCG protects non-specifically against heterologous pathogens, including TB, sepsis, respiratory infections. It's been published in some amazing journals. It's also been demonstrated through controlled infections in humans. So, how does it work? Oh, sorry. Following BCG, an initial response and a return to baseline, exposure to a second challenge induces an enhanced response, enhanced pro-inflammatory cytokines, enhanced phagocytosis, enhanced microbial activity, driven by cells of the innate immune system. So they show memory. They develop de facto memory to certain types of stimulations to improve host defense non-specifically to pathogens. Let's take a little bit of a closer look as to what happens inside the cell. It's dependent on PRR recognition of the stimulus. Depending on the stimulus, we can induce epigenetic changes, which alter gene function and enhance pro-inflammatory cytokines. Activation of the cell also causes metabolic activity within the cell. There is a shift to glycolysis and TCA pathway. This is important to an activated cell because it's a source of energy, cholesterol, and lipid synthesis. It helps in the process of producing what they need to produce. Metabolites produced through these processes are also epigenetic agents, such as fumarate, which can, in their own right, induce epigenetic modification of the landscape. Now, this has been shown in a variety of cells in the periphery. It's called peripheral trained immunity. Importantly, it's also been demonstrated in bone marrow progenitor cells. Now, this is important and explains the long-term effect of trained immunity, because these are the cells that seed the tissues in the periphery. Most of the myeloid cells in the periphery, or innate cells, are fairly short-lived. This has been termed central trained immunity. Now, thinking back to misguided immune responses, trained immunity can also be misguided. We can end up in a situation of chronic hyperinflammation or indeed tolerance. So trained immunity is now referred to as the long-term epigenetic and metabolic reprogramming of transcriptional pathways and function of innate immune cells that are evoked by a range of endogenous, exogenous antigens and lead to altered response to a secondary challenge. There's also the potential for detrimental impact when we use innate immune training agents. I'm sure I hear you all thinking, okay, always upregulating pro-inflammatory responses maybe not a good idea, particularly in the case of underlying chronic diseases and also during early life, in pregnancy, immunocompromised patients. There is a big potential for detrimental impact. Shifting slightly fields, along the same times that we were all learning about trained immunity, there was a series of seminal studies that demonstrated training immunity in nature. This involved seminal observations made on traditional European farming environments and traditional versus industrialized farms in the USA. Epidemiological observations demonstrated profound protection in the children living in these traditional farm environments against allergic diseases and early infections. The protection was mediated by exposure to microbes through the respiratory route in barn dust microbes and through the gastrointestinal route through unpasteurized milk. It was due to exposure of the pregnant mother, implying transplacental effects of trained immunity in the child, and also through exposure of the child. It's been replicated in multiple locations. There are innate and adaptive changes, and in vitro and ex vivo human studies have provided some mechanistic insight. Summarize this quickly. To demonstrate hallmark characteristics of trained immunity that we've just talked about. It's TLR dependent. It activates and matures, induces epigenetic modification of innate cells, conferring functional competence. There's direct sensing by the maternal immune system, and there's also evidence in the child of regulated development of immune competence. Strikingly though, the strongest signal was enhanced immune regulatory function, which is really important in maintaining that balanced immune response. To summarize, these traditional farming environments induce activation of innate and regulatory pathways to equip the infant with the capacity to appropriately shape and calibrate downstream responses and prevent infections. Slightly different world again, same timeline. There were beginning to be an explosion of publications documenting other types of immune-based trainings, all using microbial-based products. The most well-publicized of these are things called polymicrobial lysates. These include MV130 and OM85. OM85 is the thing that I have been using in my studies, which I'll talk about in a few minutes. There's a lot of literature out now. The majority of them document reduced respiratory viral infections after OM85 treatment. This is in terms of reduced number, severity, febrile time, duration, antibiotic use, days off work, wheeze. This has been shown for influenza infections, RSV infections, RV, and there is a potential that it might have some activity against SARS-CoV-2. It's been demonstrated in infants, children, and adults, including adults with COPD and HIV. What is OM85? It's manufactured by a company called OM Pharma. They're based in Geneva, Switzerland. This originated some years ago in 1937 with the bright idea that if they took a whole lot of respiratory pathogens and made a lysate and mixed them up, it would act like a vaccine. So that's what they do. That's how they make it. There are 21 strains of respiratory pathogens in there. Through chemical lysis, they make chemical lysis and purification. The product is formed and generally is taken orally, although there's now evidence that it works equally well intranasally. In part, it works through the gut-lung axis, whereby it activates myeloid cells within the gut, and that immunity is transferred to the mucosal in the lung. This also has an impeccable safety record. It has been used from ages 0.2 to 78, including, as I say, in immunocompromised. Overall, again, OM85 demonstrates key attributes of immune training agents. It's dependent on PRR engagement and activation of the key signaling pathways. It acts on a variety of innate cells. It provides broad, non-specific antimicrobial, cellular, and humoral immunity. It increases expression of cytokines and chemokines to control inflammation and recruitment. It increases type 1 interferons critical in viral infections. It modulates key pathways that are involved in inflammation and that can potentially contribute to exaggerated responses, such as the IL-1 inflammasome axis. So OM85, the studies describe a trained immunity that promotes antimicrobial responses. There is also a strong regulatory signal when this product is used, evidenced by enhanced production of immune-regulated cytokines such as IL-10, but also Treg cells. So some decade ago, based on the farming environment, my question was, does OM85, can we use it as a treatment to prevent asthma? We published this, you can, and since then, several other studies have shown the same things. On the back of that, and the back of the fact that it prevents respiratory infections in children, we developed the first phase 2 double-blind randomized placebo-controlled trial in infants aged 3 to 9 at high risk of developing asthma. The summary of the findings was that in the OM85 treated infants, the time to first SLR was significantly longer. The cumulative frequency of SLRIs was greater in the placebo group, and children in the placebo group had more days of SLR than those in the OM85 group. Mechanistically, it resembles trained immunity. We see activation of myeloid cells, increased Treg cells. We see a shifting of the inflammatory program that's induced in response to stimulating agents. There are now a number of trials underway globally evaluating the use of OM85 in the prevention of wheezing episodes, largely attributable to viral infections in children. Now, I took this a little bit further, thinking back to contextual situations of when pro-inflammatory responses might not be so great during early life and pregnancy in particular. I wanted to explore whether there were opportunities for trained immunity during these times of life that could offer benefits. So we set about developing a whole lot of preclinical models, treating a pregnant mouse with OM85, disease models in the pregnant mice, and then disease models in the offspring of the mice who had never seen OM85 themselves. We extracted a huge array of immune cells from a huge array of tissues and performed cellular and molecular analyses. So let's have a quick look at the results. In terms of maternal influenza infection. Following OM85 treatment, significant reduction in disease severity. Now, pregnancy and influenza causes exaggerated disease in pregnant women, and it's been the cause of several pandemics. We see significant reduction in disease severity in a pregnant mouse. We also see stabilization of inflammation in gestational tissues. And we see protected fetal growth and development. We see exactly the same things in an LPS model. Now, LPS, or lipopolysaccharide, is a renowned hyperinflammatory stimulator. So this was an interperitoneal model. And again, we see protection against death. We see stabilization in gestational tissues, implying stabilization and protection of pregnancy, and improved fetal growth. Mechanistically, looking at transcription profiles, how this pans out is that without OM85, you see the induction of huge pro-inflammatory networks that actually overlap with primary antimicrobial responses. Things become exaggerated. With OM85 treatment, there's a segregation of these responses. The pro-inflammatory response is controlled versus the primary antimicrobial response, which is maintained or elevated. So protection is mediated by selectively constraining pro-inflammatory and antimicrobial responses. In a model whereby, following treatment of the pregnant mother, in 2-day-old neonatal mice, we infected with rhinovirus, mimic. Oh, sorry. Without OM85, the model was delivered to have 25% mortality. With OM85, 100% of these neonatal pups survived infection. We've also used it, of course, in our asthma studies, studying the offspring mice to see whether they are resistant to development of allergic diseases. And indeed they are. OM85 treated in blue, they don't develop airways hyperresponsiveness. They have decreased eosinophilic inflammation, enhanced regulation, again, enhanced Tregs. There's a strong immune regulatory component turned on together with the antimicrobial component. We also see key indicators of trained immunity. We see enhanced myelopoiesis in the bone marrow. We see a strong regulation of the pro-inflammatory response, whereby we still get a lovely response. It's just constrained, much like in the pregnant mothers where we looked at the LPS response. Transcriptionally, we see upregulation of cholesterol pathways. We also see upregulation of key cytokines, key genes involved in DC survival. So, in summary, maternal and transplacental benefits of OM85. There are many. We described direct maternal and fetal effects and transplacental effects mediated in the offspring. Of course, let's consider the detrimental impacts. There's now a growing body of literature where OM85 and similar training agents are being used positively in various malignancies, cancers, and also across immune suppressed patients or immune deficient patients. So landing us back to vaccines.
We're just about to lose our online.
Yep, this is the last slide. Landing us back to vaccines. This is something I think as we need to bring back into the vaccine world, innate immune training together with adaptive immune training. So thank you for listening.
I've got one question. A question about the original sin and trained immunity. Is the original sin a positive effect of the trained immunity, or maybe a mistake, or where do you think it fits in that?
The original sin, I think it's a positive in terms of the vaccines being able to cross-protect against heterologous diseases. It's context dependent as well, though, your answer.
Okay. So thank you.